First, I'm going to make a brief presentation of who am I. My name is Alfonso. I live in Madrid, in Spain. Right now it's time for siesta, so I'm glad that everybody's here. Well, I've been working with Spark, Scala, like more than 5 years. I consider myself a functional programmer. I try to do some things for the open source community. Normally I work with big data projects. Right now I work in Habla Computing. That is the company that paid me the trip, so I have to talk a little bit about them. It's a small consultancy. We are focused mainly in functional languages. We try to go to companies to help them or to help them to make cores for the business, to make DSLs. And well, we are a group of 8 crazy people. So if you're interested, come later to me and talk with me. And well, also, this project I'm going to talk about is part of work that we are making in Habla. I have the opportunity to make this and show it to the world, so I think you should find interesting. We have the agenda. It's going to be a live code session, mainly. First, we're going to see the problem of working with complex types in DataFrames, how to solve them in a no-Spark world, and then how to make this approach into a Spark world. And how many of you are Scala developers, Spark developers with Scala? Right, very nice. How many of you know about optic libraries? Okay. So the rest of the people, you will learn something, and the people that already know about optics, I think that you can find this interesting. And well, the problem normally is, I see it like mainly maybe in streaming processing, that your client sends you JSON files that has a lot of nested elements, and you want to keep that structure because you want to save in Parquet or into the database or I don't know, Cosmos DB, Mongo, and you want to keep that structure, but maybe sometimes you have to make a few changes, like the dates, the timestamps, they're not in UTC format, or I don't know, you have to standardize some strings, all lowercase, and when you have to transform these things, for some reason you cannot use datasets, then you have to use DataFrames, is very hard. So let's see first a small example. I think everybody sees it. The people from the back, if you need something like make that to, okay, thank you. So we'll try to make it a little bit bigger. Well, we are going to start our Spark session, nothing new for you. And I'm going to be talking about this meanwhile. This is going to be our example. This is the employee that we want to make some changes with it. And this employee has a company. The company has an address. The address has a street. And the street has a number and a name. It's a complex structure. I'm going to show you first with case classes because I think it's easier to read. And we are going to make an example of our employee and make a Spark first DataFrame with this employee. Yeah, compilation fail. Or using Spark defaults. Okay. Oh, sorry. Try to go very fast, but okay. So we are going to have our employee data frame, and we have this schema that is exactly the same that we have with the case classes. When you want to make a change to one of these columns, it's, well, in the first level, it's very easy, like at select, at the frame, at select. And I want to, for example, uppercase. Well, first I'm going to show that. I'm going to per the column name. And well, I have to keep the same structure, so I have to give it the same name. So as or alias, name, and the rest, the other columns, exactly the same, the company. So I'm going to, we have our data structure, data frame, that is the res 6, with the print schema, and also we are going to make a show too, so that is exactly the same. 6. Everybody says that making a live code session is an awful idea. And well, we see that we have our uppercase John, that was the name. It's very easy for the first level, but we are going to try to do with the second level. Let's do this with our DataFrame.select. Well, so the name is going to be the same. You don't have to make any change, but we have to, if we select only the company name, we are going to select only that column, and we are going to bring it to the first level. So we have to reconstruct everything that we are going to do with the struct function of Spark functions. Right now we are going to use the name that we are going to upper. For example, our name. We have to keep the same name as name. And the second one is going to be exactly the same. Our address is going to be the same. And also the struct, we have to keep the same name. So this is the company as company. So we are going to execute this one. And well, for sure, I have still here the upper. We have to close this one. And I think that structure here, we have to also close the structure to keep the same name. So you see it's quite hard, still have problems. Sorry, here. And well, name, the select, close it, well, okay. Company, oh yeah, sure. So, well, you see that company, that name as name, and company, that address. Thank you. Res 11, that print schema, and res 11, that show false, to see that we have our awesome company, uppercase. Well, normally this talk is a 1 hour talk. The only difference is that I try to do is make a change in the 4th level. So you can imagine that, well, this is going to be a trick. I think this is quite hard. I don't know if you use structs in your daily work, but I wish you don't. Well, it's quite hard. And it's something that, well, I realized that, well, you're working with DataFrames and immutable data structure. You have to make like a copy of your data frame with the changes that you want to apply. And this was quite similar to the case classes. So I tried to show how you can work with case classes in Scala. I'm going to remember our employee, or the example that we are working with. And I want to make a change in this employee like the previous one. So I'm going to make a copy. That is the method that we have to make this change. So, well, I have to use a method. Then I have to put the name. It's going to be the name of the E to uppercase. And this works. OK. Well, it's easy. Let's do a second level. That copy, we want to change the company in this case. It's going to be e.company. That copy, because we don't want to apply exactly the same company, we want to make a modification. Copy, and the name is going to be e.uppercase. company.name to uppercase. And, well, it's quite similar. I find it has a huge problem because, well, we are coders. We are not paid for the number of lines. We are paid by the implementation, the history points, or the amount of work we take out. But this doesn't help us. I think that for me, you cannot focus in the logic that you want to apply. You have to focus in the API to transform these things, and it's not useful. So luckily, with case classes in Scala, we have a library called Monocle that is an optics library. Optics library is like a collection of optics, but we are going to focus only in the lens factory. Lens optic, sorry. A lens optic is utility to focus in a single element. And we have 3 methods. Well, first we are going to create a optic. In this case, it's an optic for an employee. And in this employee, we want to focus in the name of the employee. And with this single line, we have an object, type, lens of employee, and string. String is the type of the name that we are going to use. And we have 3 main methods. We have the company lens, that is a function that we provide an employee in this case. We will have the name of the employee. Okay, well, it's a getter. If you come from Java, it's from your plain Java object, it's a getter. Okay, also we have a set, company lens set. And we can provide something we want to set. In this case, it has to be a string. And we want to set to Jane. And we have return a function that from an employee, it returns another employee. So if we apply this function, res19 with our employee, we have exactly the same, except the name of the employee changed it to whatever we wanted. And we have a third method. It has company lens modify. Modify expects a function from a string that is going to be the previous name of the employee, and we can make any modifications. For in that case, is going to be the employee is going to be the name, sorry, is going to be to uppercase. In this case, is a function from string to string. And we return also an employee to employee function. If we apply to this one, 21, the employee, we have our employee name uppercase. Well, we have like externalized object that is the getter, the setter, and in mixture of these 2 methods is the modifier for employees' names. But lenses, optics in general, is not only a good setter and getter. It's also an element that is composable. If we make 2 lenses, for example, val employee company is 10 lens from employee, and we extract the company. And we have another lens that is val the company name. And it's from a company. We focus only in the name. We can compose them into a new lens that is going to be, employee company name. It's going to be easy compose lens with the company name. And we have, this type is a little bit more complex, but we have from an employee to the company name, that is a string. And we can do the same 3 methods that we already have with the previous lens. ECN modify for being brief. And we have to provide a function from string to string. So we are going to uppercase. We have our employee-to-employee function, and we are going to ECN that, well, sorry, res26, and pass our example employee. We have our awesome company uppercase. So it's very good, a form way to work, focusing only in what you want to do. You don't have to use the API to transform. You only focus in the modification that you have to do. And this is something that in some projects that I was working with, I found I was also a problem with Spark DataFrames. So we wanted to do something like very similar to work with complex types in Spark and make it easier to work with them. So we make the Spark optics library. So you only have to import, well, in your SVT or maybe in the dependency, and these two elements. And we have also lenses, but well, we see the differences that we were working with case classes. Case classes are statically typed elements, and data frames are dynamically typed. So we know that it's going to be 100% equal the way we work. But well, let's see what we are going to need. We are going to first make a employee name lens. So we have to do val employee name lens for DataFrame. Well, yes, yeah. And it's going to be lens. The first element that we need in this case is the focused element. And in Spark, normally when we refer to one of these elements, it's going to be a column, and the main way is a string with the name of the column. So we have to pass the name. And the previous lens have the type of the focused element, that was the column, and the general one. In this case, we don't have a type. We only have row, because data frames are data sets or row, but it's not enough. What could be the same thing in a data frame as the type that we are working with? It's in the schema of the data frame. So we already have our data frame, so we pass our schema. Okay, well, I'm going to do it again to have a new line. And a few lines more to put it on top. Okay, so right now we have an optic lens for work with data frames. And which methods we had previously? Well, we have the same three methods. We have the end3, like, then get, the getter. And we cannot get the name of the employee because we are working with data frames. So what we are going to have is a column, the reference of the element that we are working with. We are also going to have the endf, that the setter. And if we're expecting, well, we were returning with the getter a column, we are expecting also a column. In this case, well, we can put a literal that is going to be Jane, I think I put later. And it's going to return us an array of columns. This array of columns is exactly the columns to keep the structure exactly the same and put the Jane in the name of the employees. All the employees in the data frame are going to transform to Jane. So we are going to show it. Well, data frame that select res32, and this is an array. We have to, I always have a rule and call this the keys. You have to pass the keys to make an array into a, and we are going to show first. So we have Jane, we had more employees, and also we are going to see the data frame, the previous one. I'm going to copy and paste. Don't do this. I told you. Print the schema to be sure that everything is exactly the same. Okay, we have the same schema. But this is not a quite good way to work, because a data frame really is a collection of employees. It's not a single employee. And in the previous example, it's not exactly one-to-one relation. will be like more like something like a list of employees that I want to map with the function of our optic that modify, for example. And this will be exactly the same to work with data frame, real data frame. Well, yeah. I'm not going to present it, but thank you. Modify. Yeah. Optic. So this will be what we really want to do. So we have an alternative to the setter, that is the end f that set, and we have an alternative that is set data frame. Set data frame, well, we put the literal that we want, Jane, and it will return us a much better thing that is a function from any data set to a data frame. So we can use this one, res 35 with transform, or directly passing the data frame that show false. Okay. And also we have a modify function that is going to be end f that modify. Yeah, we was cooking, right? And modify expects a function from a column to a column. So I can, for example, upper, I will return, in this case, I'm going to put modify data frame. Also, we have this alternative. And we also have this function, res37, with the data frame, and it's going to be so, works exactly the same. We uppercase the name of all our employees. Okay, and also I told you that lenses are composable, and these lenses are not less than other lenses. So in this case, we can create two new lenses. Well, employee company data frame, and it's going to be lens, and I'm going to pass the company, I'm going to pass the data frame that schema. Okay. And also I'm going to do the second one. That is going to be it was going to be the company name, data frame. It's going to be the lens and the name. Okay, and I'm going to pass the schema of, it's a substructure. And also I told you that this is a short talk. And to struct the structure of a sub-element, it's a little bit complicated. So why don't we leave it for later? Why? Because if we are going to compose two lenses, if the first one has the structure, the second one has to check that he can fulfill that structure. In this case, ACDF, compose lens. Well, it's not a lens. It's almost a lens. It's what I call the proto-lens. And we can compose it with the CNDF. So we have the res32. Let me assign it a name. Employee company name, data frame. And so, okay. So we have a lens. Also, look at the lenses. Always try to show you, has a toString method that it tries to show what is inside the company name, and we can do everything that we wanted. ACNDF, that modify, and the upper, and we pass the data frame to be very fast, so false. Okay. ACDNDF. Yeah, sorry. Sure. People that the F and the so false. Okay. So we are only focusing in what we want to do, not in the API to reconstruct and do the selects and all those things that for other people is quite useful, but for us that we want to do something different, it's not so useful. I think that is quite nice. And we are seeing that, for example, that we are working with DataFrames, and I'm going to make a lot of modifications, but not all the modifications wasn't true to you, were exactly the same schema. If you saw that, well, if you have worked with Spark, if I created that employee, the employee, all the elements are nullable, for example. So if when I put a literal, everything that non-null or null is going to transform into a non-nullable column. So the schema is a little bit changed. So we can be sure that all these modifications that we are doing are correctly fulfilled if we apply a third variation, that is modify data frame checking schema. If I put, for example, the upper, it's going to be OK. Data frame, that's so false. Oops. OK, so it's OK, but for example, if I use, I'm going to copy to make it this a little bit faster. Set the schema. Sorry. Set, and I'm going to put, well, it's the name of the company, but we want to put a literal 3. So what will it happen? We have original column type was a string type, and we are trying to change to an integer type. So we have a runtime error in this moment. And also, well, if this is quite good to make some changes and be sure that that any modification that I was doing is not ruining our schema. And also, well, you saw the lenses, and also when you compose the lens, like lens was the company, and we put the data frame, and we want to compose with a proto lens, for example, that is a lens with something that we are going to have runtime errors. So we are not going to create anything that, if we already know the schema, is going to fail. So normally try to have all your possibly error code the first, and then run in the job of the Spark. Okay, so well, we are already finishing, and we have a couple of things more to tell you. That, well, lenses were working with statically typed case classes, but we have data frames. And data frames sometimes, well, we can change a few things. And sometimes also these lenses could be useful to make transformations that are not structurally safe. Like, for example, we are going to keep the ACA employee company name data frame. We can, for example, rename the column name. So we can choose a new name. For example, the company name is not going to be the company name, it's going to be the company nombre, is in Spanish. So we can make this change. We are going to have an array to array. And I'm going to apply this one. Data frame that select, res53, and the keys, that print schema, because I think it's the only thing that we want to show. We have the company nombre in this case. So it's quite useful to make these modifications without reconstructing the struct, putting the same columns, only to change a name. What else we can do? Well, if we can rename, we can also, data frame that select, we can employee company name data frame, prune that element of the structure. If we prune it, always remember the keys, print schema. We get rid of it. We no longer have a company name. So maybe sometimes we have the data in our data lake, and we are going to make a data frame for our data scientists, but we don't want to give them all the code, and it has a complex structure. We can do it very easily to get rid of those columns that they don't need, only applying a few optics that we have in this case. Let me check, because I think that we don't have any enough left. But yeah. So I'm going to back to the presentation. A quick recap. Oh, this is the repo URL. Also, if you want to try it by yourself, you have a binder that is already put it there. You have only to click in the button, and you can have a, I think it's like 1 hour or half an hour notebook for free. You can run a Spark context, and you have a lot of examples like this one that I showed you. And it's quite useful. Well, the whole presentation. And schema changes functions, the prune, the rename. Well, feature work. Well, this right now is only a Scala library. I don't know if maybe it could be useful and can be done with Python. I'm not a Python guy. Also, well, we want to bring new types of optics. Mainly, for me, the most important is the traversable. But right now, well, the whole library is made with the public API of Spark. And the traversable, since 2.3, we have a function to sweep elements that is quite nice, but it doesn't keep the columns names. So it's not enough for, I don't know if it has changed. Also, well, to see is something that we can apply to the insides of Spark to make it faster, to well, create less objects and use less the public API. And also, well, another thing that we have planned to see is that this is possible and it's useful to make a compatibility with other APIs that we have in Spark, like the frameless. That is a typed dataset API that, well, you can also see your errors, typing errors in runtime, in compile time, sorry. So it's quite interesting. Well, thanks for interested. So you have the link for Monocle. It's a great library. The Spark Optics one. Also, Habla Computing and my own LinkedIn and Twitter. So if you want to reach me through social networks. Well, any questions? Thanks for coming to this talk.
Thank you for the talk first. I was wondering if you could give some advice of how to order projects, because one of the characteristics that I've seen using lenses that it's become pretty messy. So people who don't know where to look for it, it's become really unclear. So do you have any ideas how to order properly the project and the lenses to make it kind of more usable?
Okay, the lenses, well, it's something that depends mostly in the schema that you have in the moment. In the code, I will try to make the lenses the first, and real lenses with the schema. So you have all your possible errors previously to any kind of actions that you want to execute. So is that the question? No. The idea is try to have all the possible errors in the beginning and not wait first job that it takes 1 hour and then find that you have misspelled name and you put names. So try to use those lenses when you have the schema that you're going to use. Try to create all the lenses that you are going to need and apply it one following each other. Also, you have the methods and then that Scala provides to concatenate functions. So you can make all the logic first create the lenses, create the functions, compose them, and apply in a single action.
Thank you for the presentation. I just have one question. Can you make it work for more complex type, like arrays, for instance?
Yeah, well, as I thought in feature work, well, traversable are optics that focus in all the elements of an array, at least a collection, in these cases. The things that Spark right now it's quite hard to do these things. I think, well, I know that there's the lambdas, but only for SQL. When you're writing the whole SQL, you can make map transformations to arrays, but the problem is that you're still having the reference to put it in the first level of the data frame. You cannot, for example, if you have an array of complex structures like tuples, if you transform only one element of the tuple, you are not going to be able to compose it with the same names, with the same structure exactly at the moment. So arrays is something that we want to work because it's like the two basic things, structs and arrays. And right now, the only way to work with those arrays, I think, is the UDFs or datasets.
Thank you.
Hello, I'm curious if you can do like lens company.name. Like in the demo, you like compose two different lenses. But
Yeah.
is it possible to just do lens company.name, or is that unsupported?
I forget what thing. Well, sorry. First.
Sorry, what's that?
No, it's end your question. Sorry.
Oh, that was the end of the question, I think.
Okay. I can compose the lenses.
No. So in the demo, you compose the lenses, but I'm wondering if you can just do lens open brackets quote company.name.
Yeah, exactly. That's what I forget.
Oh, right. So you can do that. Cool.
Yeah.
Okay.
It's only going to be a second. If you want, we have also a syntactic sugar. If you want to make a more complex lens and you have your Spark developer, you can make the lens like the company that name and the data frame. I think this was your question, no?
Yeah.
Exactly. Well, okay. Val L, and you can compose this lens, and it's going to be company dataset. Sorry. Schema. Yeah. Okay, you can compose this lens. What it's going to do is create two lenses, apply to the first one the schema of the top layer, and apply it recursively to the other elements. So you have a syntactic sugar more easier than create each lens by themselves.
Okay. Thank you.
Yeah, and it's exactly the same. I'm not going to. Any more questions?
Hi, thank you for the talk. You mentioned that you would like to, during the further development, integrate more with the internals of Spark. Don't you find it maybe dangerous because non-public APIs can change over time?
Well, if we are going to see if it's possible, we are not going to touch anything that is not. This is not going to be applied to Spark if it's going to break everything. So the idea is more to try to see if it can be increase the efficiency of these elements. This is right now composing for you all the structs and the renames and all that code, and to see if there could be a better way to apply it. But it's only an idea. It's not something that's going to be developed in the next 2 months, for sure.
Okay, thank you. Okay.
Thanks for the talk. My question would be whether it was also possible to add new columns to complex types, or does it only work with the columns that are already in the struct?
Yeah, as you saw, when you're modifying, for example, or to add a new column that didn't exist previously, it's not possible. But you can reach the previous level and reconstruct the struct with a new column, for example. But the lens that you already were using is not going to be longer usable because the schema has changed. But you can use it to get to the father of that element that you want to add a new column and create it. Also, it will be a great idea to try to bring that to a method that for this level I want to create a